Number 3 says a rifle is fired horizontally and travels 200 meters. The rifle barrel is 1.9 meters from the ground. What speed must the bullet have been traveling at? Ignore friction and ignore air resistance. Okay, so let's begin by drawing a diagram of this scenario. If you have a bullet that's been fired from a rifle, that bullet's path of motion is going to look something like this. It's going to travel this direction, and then eventually it's going to hit the ground. Now notice in the problem, they told us the horizontal distance the bullet traveled. So the distance from here to here, we're told, was 200 meters. So let's label that. So the distance in the x direction is 200 meters. Okay. We're also given the height of the rifle above the ground. So let's label that. The height of the rifle is 1.9 meters above the surface of the earth. So this distance from here to here is 1.9. And even though this is not to scale, you guys get the point. So the distance in the y direction is 1.9 meters. And ultimately, what we're trying to solve for here, we're trying to solve for the initial velocity or the initial speed of the bullet the moment it was released from this rifle. So that's ultimately what we're trying to solve for. Okay, so keep that in mind as we're working out this problem. So let's do this. Okay, so remember, as we're working this out, we're going to use our displacement equation to solve this problem. And keep in mind that we're treating the y component independent of the x component. So let's start with what's happening in the y component first. Remember, you want to begin with solving for the time in free fall. So what is the time in free fall in the vertical direction? Okay, so let me go ahead and write out my displacement equation, and then we can plug everything in to solve for the time in free fall. Okay. So the question is, what is the initial velocity here of the bullet the moment it was released from the rifle? Well, that's easy. Just like before, the initial velocity in the y direction is just 0. In other words, the moment that rifle came out of that gun, at this point here, it was moving at 0 meters per second, and of course, it began to speed up because of gravity, but the initial velocity for that brief moment in time was 0. So let's plug this in here. If I plug in an initial velocity of 0 into this equation, this part of the equation goes away, and I'm just left with this. So my displacement in the y direction is 1/2 multiplied by acceleration multiplied by time squared. Remember, we want to solve for the time in free fall. So in order to do that, we need to plug in the displacement. We're given the displacement in the y direction. The displacement was 1.9 meters. So let's plug that in to our equation. 1.9 meters. We know the acceleration of gravity is 9.8. And we're trying to find the time in free fall. So I'm not going to go through the algebra here because by now you guys should know how to solve for t. Turns out when you work this out and solve for t, the time in free fall for the bullet is 0.62 seconds. Okay. So that's how long the bullet spins in the air in the y direction. And of course, logically speaking, if the bullet spins 0.62 seconds in the air in the y direction, it obviously spins 0.62 seconds in the air in the x direction. So let's go up to our horizontal component and let us determine what's happening there. So once again, let us write out our equation for displacement. Displacement is equal to initial velocity times time plus 1/2 times AT squared. Now, the question is, before we plug anything in, the question is, what is the acceleration in the x direction? Well, remember here that there are no forces acting in the x direction. So if there's no forces acting in the x direction, the acceleration must be 0. The object's moving at a constant velocity. So if I plug in an acceleration of 0 into this equation, this part of the equation goes away because 0 times some number is just 0. And of course, this equation just reduces to displacement is equal to initial velocity times time. Okay. Now, we have the time in free fall. Remember, we saw for that. The time in free fall was 0.62 seconds. So I'm going to take 0.62 seconds. I'm going to plug it in here. So 0.62 seconds. We also know the displacement in x because we're given that. We're told the displacement in the x direction for the bullet was 200 meters. So I'm going to plug in 200 for my distance. And obviously from there we can find the initial velocity. In order to solve this equation for the initial velocity, I would just need to divide. If I divide this by 0.62, that goes away. Whatever to the one side, I have to do to the other. So when you do the math, the initial velocity in the x direction should be 322.6 meters per second. So that's how fast that bullet was moving the moment it was released from that rifle. And of course, it stayed at a constant velocity the whole way because there's no forces acting in the x direction. So let me plug that in here. So 322.6 meters per second is the speed the bullet was traveling at. So that's number 3.